Hello again. In this short course, I'm showing you how you can use the very powerful features of the Amazon Virtual Private Cloud to secure a microservice-based architecture. Our general aim is that we're going to make sure that all of our microservices instances are launched into private subnets. And when they're launched into private subnets, they're not going to get an IP address, and therefore no evil hackers are going to be able to access them directly. So we don't even need to think about applying any kind of security layer to the individual instances. Well, I left things at a cliffhanger in the previous chapter. Everything appeared to go well. We've launched this microservice called Position Tracker. It does not have a public IP address. It does have a private IP address, which means it will be able to be used by other instances in the virtual private cloud, but nobody in the outside world will be able to directly see it. However, when we ran our build, everything was going well with this instance until we got to the stage where it was trying to upgrade the packages on that instance. We got this absolutely horrendous error. So what's going on here? Well, let's do a little bit of research. We know that the private IP address for me is this one here ending .114. It will be different for you. And as we saw in the previous chapter, that means we can't connect to it from a Cygwin instance or your terminal because it's a private IP address, and this IP address simply doesn't exist in the outside world. This is hanging. It will never connect. So the way that we access an instance is by using what's often called a Bastian server. And a Bastian server is quite simple, really. It's just you connect to any public instance that's part of that VPC, and then you can connect privately to one of the instances. Now, it would be called a Bastian instance if the only reason you've launched that instance is so that you can connect to some private instances. But actually, we don't need a Bastian because we have our Ansible server, our Ansible controller, which does have a public IP. So I can connect to that, and then I can do a hop to the private address of my position tracker, the address ending 114. Confirm that I want to connect, and here I am. I am now on that private instance. Now, we saw from the Ansible script that it was failing at the point we were doing the yum update. Well, I would actually need to run that as sudo. So let's see what happens. And yeah, we have a big error. I don't think the error is particularly readable. There could be a clue there, this base URL. And actually, any operation, such as an install, so we need to install Git onto this instance so that we can download the code for the microservice. Well, that's going to fail. I'm not even going to bother waiting for it. And you might have started to get a feeling for why this isn't working. Let's review what we have on a picture. We've launched an instance here into our private subnet. And we know that we can't connect to that private instance unless we use some kind of a public instance that's in the same virtual private cloud. So we also have a public subnet, and we'll have some kind of a Bastian instance. In our case, we don't really need a specific Bastian because we've been using the Ansible control node, but we've been using that as a form of Bastian. Now, one thing that we've never mentioned so far in the course, it's always been there in our Amazon account, but it's never something that we've had to look at specifically, is that in fact all of the traffic coming in from the outside world is going through a piece of hardware called an internet gateway. Now, that's just attached automatically to our VPC. And I don't really know how much we need to know about this internet gateway, but I thought I'd better mention that it is there. So when we just made our connection using Cygwin a few moments ago, we were going through the internet gateway into the public instance on its public IP address, and then we were doing a hop across to the private instance on this private IP address. Now, we've observed that when we try to run a yum update on this private instance, everything is failing. And you might now be able to see why. In order to do a yum update, this private instance has to contact the internet. It has to make a request to some IP address somewhere. Now, I know that this diagram is very basic, and I'm certainly simplifying heavily here, but I hope it serves to illustrate that the problem is because our private instance has no direct connection to the internet, as well as traffic not being able to get into the instance, or at least unless we use this Bastian, it also means that traffic can't get out. And to put it another way, really, if you have a machine that does not have a public IP address, it can't contact the public internet. As simple as that. So we need a solution for this, and the solution is, if you want to think about it in very simple terms, is the same solution that we used for the incoming traffic. Is that what we can do is we can introduce an instance into our public subnet whose specific job is to be able to send traffic out to the internet gateway. Now, I'm trying to keep this in the simplest possible terms, but you might have come across this concept elsewhere. It's called a NAT instance, where NAT stands for Network Address Translation. The reason you might be familiar with this is exactly what your router does. If you happen to be using a computer right now that's connecting to a router, then your computer probably has a private IP address, but your router contains a NAT server, so all of your outgoing traffic from your computer is actually going through this NAT instance. Now, what we can do in our entire virtual private cloud is just have one of these NAT instances, and then all of the microservices, even though they will have lots and lots and lots of different private IP addresses, they can then send outgoing traffic through the single IP address that will be attached to the NAT instance. So although this is quite complicated, and I'm trying to simplify it as much as possible, in terms of the picture, it's just a simple case of when we have outgoing traffic, it will now be diverted to the NAT instance, which, because it's public and it has an IP address, it can communicate with the internet gateway. So I hope this looks relatively simple, but the complexity is, I'm afraid, we do need yet another EC2 instance just to perform the work of this NAT instance. And you do need to allocate an IP address to that NAT instance, and that means you are going to need to use yet another elastic IP address. So it is a little bit awkward to set this up. In fact, relatively recently, I don't know exactly when this happened, but yeah, it used to be the case that you literally had to go and launch an instance and go through the usual EC2 route. But they have recently made it a lot simpler to do this. You can do it using a wizard effectively. And you do that by going into the VPC service. And on the list here, you'll see there's an element here for NAT gateways. Now, according to the summary here, I currently have none of these in existence. This will be my first. And I've got to warn you before you do this that a NAT gateway is once again going to incur ongoing costs. So it might be that if you're watching this video and you get the idea, you might not need to go any further with this. If you really do have a burning desire to try this for yourself, then feel free. But once again, the same warnings as on the previous course. Please make sure that you delete this NAT gateway once you finish with the example, because it can be quite expensive to run. So with that warning in mind, we'll create a NAT gateway. Now, the difficulty with creating this is it doesn't give you a lot of clues as to what it's looking for. It's first of all asking us for a subnet. And actually, it's one or more subnets that we can put in here. Now, this is simply asking us which of our public subnets do we want this NAT instance to live in. Now, it absolutely doesn't matter which of the subnets it's in, as long as it's one of the public ones. So when you click on here, you get a list of your subnets, I'm going to go for, just to be a bit random, really just to prove it doesn't have to be the same availability zone as your private subnet. Now we're deploying our microservice into the private subnet. I'm going to choose to put the NAT instance in public C. Once again, to confirm, that could have been any of the public subnets. Next, we need to give the NAT an IP address. Now, we don't have any elastic IPs available, so I'm going to need to click on Create New EIP. And all as part of this wizard, it's now automatically created a new IP address, which is now permanently bound to this NAT instance. And that's this one here. Now remember, EIPs cost you money. So be sure to deallocate this EIP once you've finished with it. So although it is a little bit tricky this, the wizard's quite simple. I can now create that NAT gateway. Now it's warning us that in order to use this NAT gateway, ensure that we edit our route tables. So we'll take the advice and click on Edit Route Tables. And I can tell you that what it's expecting us to do here is to create a route table and to correctly configure it. But we're not being given any advice as to what these route tables are all about. So let me try to explain them by, first of all, switching across back to our subnets. And I'm going to pick one of our public subnets. Let's go for public B. And there's some tabs down here, and one of the tabs is route table. So what we're seeing here is a table which is going to be applied to any instance that is launched in the subnet public B. So for example, it could be that our public instance here, the Bastian Server, is using that route table. Now this route table is relevant to outgoing internet connections. And what the route table is saying, if it's trying to contact an address beginning 172.31. anything else, then that network traffic needs to be routed locally. And that's why this has been working. If I'm on this instance and I try to connect to 172.31.63.114, then the route table is telling it, that's internal traffic, and therefore it looks for an instance in this VPC. Now we have a second row in the table, and this is saying that if the IP address for the outgoing connection is anything else, so this 0.0.0/0 actually means any IP address, and it goes through the table in order, so it will check this first, and then if it doesn't have a match, it's saying that the destination for that traffic must be this rather odd looking thing here, IGW-. You'll see something slightly different there. So what's that all about? Well, if I click through to it, because it is a link, it brings us onto the Internet Gateways page. So in other words, it's saying that this instance, if I try to connect to any IP address other than 172.31. something, then it needs to direct that outgoing request to the Internet Gateway. Now, as I mentioned, we've never created that Internet Gateway, but it was created automatically when we created the VPC. It represents a piece of real hardware in the Amazon data center, but we don't really need to think too deeply about it. Other than, if I go back into the subnets, back on this public subnet, you can see now that this is how the virtual private cloud knows that any address apart from those needs to go to the real global internet. So I hope that's not too complicated. I'm no great networking engineer myself, and I'm trying to keep this as simple as possible. But what that means is now, if I select one of my private subnets, the default route table we have here is not correct. This is saying, same thing as before. If a private instance is trying to access an IP address like 56.32. something, it's going to use this route table and it's going to try to go to the Internet Gateway directly. In other words, what we've got here incorrectly is this. The private subnet is trying to access a public IP address, like, for example, the Yum repository, and it's going straight to the internet gateway. And that's going to fail because a private instance simply cannot talk to the real internet directly. What we need to do, we need to rewire things so that this private instance is routed to the NAT instance. And the NAT instance can talk to the internet gateway. So I hope I've not over-explained that, but I just remember the first time I had to do this, it was an absolute nightmare. I didn't know what I was clicking, I didn't know what I was editing, and I ended up in a real mess, and I don't want that to happen to you. I have to say the user interface isn't particularly easy here. We want to edit this private subnet. If you click on edit here, that's no good because all you can do is change to another root table. We've only got one root table defined. So what that means is we need to cancel that, go into root tables, there's the existing one, create a new one and give it a good name. I'm going to call it NAT root table. Make sure it's in the correct VPC if you've got more than one. Once it's created, then we can go to the bottom here and we can do some edits. Now, it's already given us the private routing, so any private addresses will be correctly routed to the local network. But we now need to add in a new route, and this is going to be, as before, 0.0.0.0/0. In other words, any other IP address is going to be routed to, and well, you should be able to work out from these IDs. The first one is the internet gateway. We don't want that. We want to go via the NAT. So select the NAT and then click on Save. And then the final job, I hope this hasn't been too bad. If we go to Subnets, I'll select one of the private subnets, and then on the root table tab, we'll edit to use the NAT root table instead and do a save. And then we'll want to do the same thing for the other private subnet. This is B. Edit that root table, change it to the NAT. That's good. And then switch to the final private subnet, C. Edit that root table. Exactly the same as before. Now that might be a bit scary, but we are now finished. All the time I've been talking, here is my Cygwin window. You might be using a terminal where I'm connected to the private instance. And actually, do you know what? I think I'm going to demonstrate this by undoing the change. So this instance is in zone A. So for this private A, I'm going to just undo the change I just made there. I'm going to edit the root table and switch it back to the previous value, just to demonstrate that if I do a sudo yum install git, that's going to freeze. It can't see the internet. Eventually it's going to time out. And yeah, I've got a timeout there. I think you get the idea. So I'll cancel that. Certainly in a bad state. It needed several cancels. And I just wanted to do that to demonstrate it's simply the presence of this NAT root table pointing to our new NAT. As soon as that's saved, if we go straight back into there, do the same thing again, fantastic. We're now getting the usual output that you would see from doing a yum install. So really hard work that we have to do this manual configuration of a network for a private instance, but it's all very necessary. So what that means is now we can exit that instance. Going back to EC2, on our running instances, I'm going to terminate that instance just so we get back to a good position, and I'm going to go back into Jenkins. And we've reached a good point now. Let's run that build again. And with the work we've done, I'm expecting a clean build. Let's watch what happens. So here's the provisioning stage, and as before, I'll switch to my instances, and here is that new instance, currently in the pending state, no public IP address, that's good. Great, the instance is now ready, and now the crucial stage, we're on the upgrade packages task. So this is the task that failed previously because it couldn't access the internet. Another nervous wait here. We don't know if this is working until... and I did an edit on the video there because that was about a minute and I was worried, but yeah, it ran through okay. And it looks like now the build is proceeding exactly as it was before. Okay, that's fantastic. The script has run through completely. So that's nice. We now have then a position tracker here with no public IP address, so there's no possibility whatsoever that a hacker would be able to access that REST service directly. They would have to break into one of the public instances in the VPC. Let me make that absolutely clear. You have to be really certain that your public instances are very secure. A Bastian instance is always the weakest part of any private network. The next question before we finish is, this is all very well, but now that we have a private IP address, is the system as a whole still working? And to answer that question, well, of course, I could just go to the web app and have a look, but I want to show you first the Eureka server, which we've not used so far on this session. Now I have, as usual with Eureka, we have a static elastic IP address allocated to it. And we're running it on port 8010. So here's my Eureka console, and the really important thing to see here is that, remember, Eureka is running in the same virtual private cloud as that microservice, and therefore Eureka can see that microservice perfectly well. It's registered as Fleetman Position Tracker. I'll right-click on that and select Open Link in New Tab. I just want to see what that link was pointing to. And yeah, it's actually pointing to the private DNS name for that instance. So that means internally, everything should work okay. Just further confirmation there that that's absolutely not visible to the outside world. So that should mean, finally, if I go back to my web application, which I haven't refreshed for a long time, and give that a few refreshes, that's running absolutely fine with our new private instance. One last thing, I mentioned before that I ought to review the security rules for the firewalls for this instance. So let's do that. Position tracker. Here's the security group for that instance, and it's called microservice group. Now, I hope this makes sense to you that although at first this firewall looks really alarming, it's saying that from anywhere, port 8080 can be accessed, and from anywhere, port 22 can be accessed. But actually, because we've made this instance private anyway, these firewall rules are never going to be tested. They're never going to be reached, if you like, because the instance isn't reachable in the first place. So in a way, really, these firewall rules are almost redundant. Nothing's going to be able to connect to port 8080 anyway, because there's no public IP address for this instance. So I might as well actually get rid of that rule. So that just leaves us with the SSH rule. Now, we do need that. We do need a firewall rule for port 22, because of course we might need to connect to it with our Bastian server. And in fact, our Jenkins Ansible script needs to access port 22 when it's doing its initial configuration. So let me do a quick demonstration on this. I've got a clean SIGWIN here. And as usual, I will need to SSH first of all into my Ansible control. This one ending 89 is the Ansible controller. So that's the public Bastian instance. And now from here, I should be able to do an SSH into the private IP address of this instance, which of course I've forgotten. So I'll need to go into instances. And here it is. that one ending 225. Now, this is where the firewall rule is going to be tested. And as you can see there, I am able to log in. Now, if I log back out again and go back to these security rules, if I were to edit away that rule, that now means that even the instances in the private cloud are not able to SSH into this instance. So we can prove that. That's definitely looking like it's timing out. So in your security rules, you are going to need to have some kind of a rule for port 22. Now, this would depend on how paranoid you are really in terms of security. If you say anywhere, let's be clear now that what you're saying is anywhere within this virtual private cloud, because this is a private subnet. But if you wanted to, you could specify a custom IP address, and that could be, remember the IP address of the Bastian was the one ending in .89. You could be specific here, and you could say that only that Ansible controller can connect via SSH. And I should have remembered that you need to put /32 in there for a specific IP address. So that's one thing you could do if you're hyper security conscious. Another thing you could do on here is you could say that only instances in the range 172.31.0.0 / and it will be /16 for the entire set of addresses that hang below that .31. So this firewall rule is saying only instances in the VPC are going to be able to get through the firewall. So it's really entirely up to you. It's up to your own security rules and regulations. But I kind of want to emphasize that even if you've made it look very open, we're still protected by the fact that this instance doesn't even have an IP address. So only instances in the VPC are going to be able to access it anyway. So that's pretty much it for this very short module, but there was some quite nasty little traps along the way, so I'm certainly glad that I've done this video. Of course, we haven't done everything yet. I've only made one of our microservices be private. I hope you can see now that for every other microservice that we ever deploy, it's a simple case of making sure we deploy it to a private subnet. However, the web server, well, that's always going to be public, so nothing to worry about there. But one thing I've not thought about so far, what would we do with, for example, the Eureka server and the config server? Let me start with the config server. Now, I realize there's a lot to remember, but you'll recall that we've set up a load balancer for the config server, and it's this one here. So it has a public-facing DNS name, which we can access through a public browser. If we go to port 8888 and visit, for example, /env, you can see here that we are leaking that config server on a public-facing URL. So all you would need to do to make this secure is when you create the load balancer, I'll just pretend to create a new one here. It's going to be a classic load balancer. You might remember that there was an option here on step 1 to create an internal load balancer. And what that will mean, if I go through the rest of the steps, exactly as we did on the previous part of the course, what that will mean is that this private elastic load balancer has a DNS name that is only accessible, once again, from within the virtual private cloud. So I'm not going to bother implementing that simply because it's going to be quite a lot of work, because I've got to change a lot of config files to reflect that. But if you're in any doubt about that, just go to the part of the course where we set up the global config server and we set up the load balancer for it. The details will be exactly the same. So I'll delete that because I don't need it anymore. Things are slightly different for the Eureka server, unfortunately, because part of the design of Eureka, as you know, is that we need to allocate a public elastic IP to it. I think Eureka is quite a strange architecture and a strange design in that sense, but it does mean, going back to the page that I just had up before, we do have this public-facing page where there's obviously a lot of very sensitive information potentially on here. But remember, Eureka is just a Spring Boot application, so it's a simple case of setting some configuration properties to make your Eureka server secure. Now, I'm not going to do this as a demonstration on the course because it would mean rebuilding Eureka and recreating a machine image and so on. So it's not worth doing all of that work for a demonstration, but just to assure you, you can find details of this in the Spring Cloud Netflix manual. I must admit, at the time of recording, I found it a little bit difficult to find all the details. So I'm pointing you here to a Stack Overflow question. It's question 289-74752. And the answer here, which I think actually came from the original questioner, you put some config properties, security basic enabled set to true with a username and a password. And then in your clients, you add that username and password to the URL. And that's a standard way of passing credentials using basic authentication. I noticed that the person giving this answer doesn't seem very happy with this answer. And they're saying, can I find something that's more secure? Well, actually, and as Dave Sire here says, and Dave Sire is one of the authors of Spring Cloud, so he knows what he's talking about. He's rather spikily replying with, well, what's the problem with that? What would be more secure? It does seem to be true that people think that basic authentication is somehow not very secure because it's basic. That's not true at all. This is perfectly secure. That is assuming, of course, that the repository that you put this code in is a private repository. I know we're using a public GitHub, and you certainly wouldn't want to put your passwords in there. As I say, I'm not going to bother demoing that because it will be a lot of work for relatively little benefit. The point is, it's an easy thing to secure your Eureka server and your global config server. The thing I actually wanted to do on this course was show you how you can create private subnets, and then from then on, whenever you launch new microservices, of course you'll be adding lots of them in the future, you just simply launch them into the private subnet. And Eureka will pick them up automatically, and there's no chance of anybody from outside that virtual private cloud accessing the service directly. Now, very importantly, if you have followed along with me and you've created your NAT instance, then be absolutely sure before you finish to go into the VPC service and find your NAT gateways here and be absolutely sure to delete that gateway. Otherwise, it will cost. And remember, on your Elastic IP list, you will have an Elastic IP that was used for that NAT. Now, I think if you go to the Elastic IP list, you will probably see the Elastic IP address that was allocated. For me, it's this one here, beginning 52.49. Actually, I tried to dissociate it. It gave me an error saying that I don't have privileges to delete that Elastic IP. So I was a bit worried about that. And actually, I realized that it will be automatically dissociated. Just while I've been talking, I've left it on the screen, but I think if I do a refresh here, now when I've done a refresh and I select the IP address, I now have the option to release that address. So be a bit patient here. Wait until you can see that you're allowed to release it. You don't need to do the disassociate. That will happen automatically once the NAT has been deleted. But you do need to release it. And that's been released okay. So don't forget to delete your NAT gateway and the corresponding Elastic IP address. Otherwise, you're going to be charged. If you are currently running the full microservice architecture and you're finished at this point, then be sure to check the chapter on the original course where I show you how to close all of your resources down. I'd hate for you to get charged.